met someone at church who works with a campus ministry. I told them that I enjoy interviewing students and asking them to defend evolution. My favorite question to ask is, what do you consider to be the best empirical evidence that exclusively supports evolution? After all, evolution is fact, right? There should be plenty of empirical evidence supporting evolution. So I asked my friend what he would say to that question. He said, radiometric dating. Well, that got me thinking. Yes, of course. That is exactly what students are taught as proof Earth is billions of years old, and they believe evolution occurs as long as they have billions of years. Since no one can actually really comprehend billions of years, the story feels right. Anything can happen as long as you have incomprehensibly long ages for organisms to evolve. Students are taught that evolutionary scientists have a lock on how old Earth is by using various forms of radiometric dating. But is this method of dating Earth really reliable? This led me to think about our documentary, Earth Battles. How old is it? On the DVD is bonus video called Dating Rocks. It's an interview with Dr. Andrew Snelling. He addresses the topic of radiometric dating perfectly. The following is my interview with Dr. Snelling.
Well, the issue of radioactive decay, and uranium is an element that most people are familiar with, is that just like there's variety of plants, you get different coloured daisies, you get different varieties or slightly different sizes of uranium atoms. It's to do with the number of particles in the nucleus. You've got the positive protons in the nucleus, but you also got neutrons. And the electrons, the negative particles, are in shells around, zapping around the nucleus. Well, if you get uranium-235, it's got so many neutrons in the nucleus, but if you get uranium-238, you've got more neutrons. So we call those different varieties or isotopes of uranium. Now, some atoms of uranium are unstable because they're so large. They can't, the binding forces in the nucleus can't hold all the particles in. And so what happens occasionally to help the nucleus become stable, it spits a particle out. In fact, it spits out 2 neutrons, and that's the particles that become that cause you detect with the Geiger counter. The neutron splits into electrons and protons, positive and negative particles. But for the sake of the argument, it spits out the particles, and that's what you detect with the radioactive decay. And so it reduces the size of the nucleus. It reduces what's rotating around it because of balancing everything with the electrical charges. And so it changes to a different element as a result of the change in the nucleus and the change of the balance of everything. So we call that radioactive decay. And it's a random process. And some atoms, unstable atoms, do it more quickly than others. So, for example, potassium, you've got potassium 36, 38, 39, 40. Potassium 40 has so many neutrons, it is unstable, so it decays, and it decays at a faster rate than uranium. Potassium, it's about just over 1 billion years on average for what we call the half-life. It's a measure of the rate of decay. And with uranium, it's 4.5 billion years. And of course, that's the rate that's measured today. We have to understand that. When they quote you a radioactive decay rate, it's the rate that's measured today. But the interesting thing is they've only been measured in the laboratories for the last 80 to 100 years. And so what they're saying is that we can take 80 to 100 years worth of experiments and extrapolate that back 4.5 billion years. Now, if I did an experiment in my chemistry laboratory and you know, in 5 minutes this happened, and then say I'm going to extrapolate that back, you know, 5 billion years, naughty. That you can't do that. That's a gross How can you assume that it's been constant over that period of time? You know, you can't take a teeny little bit of data here and extrapolate it orders of magnitude out there. You have to have good reason to know that it's been constant to be able to even begin to suggest that it has been constant. So the present rates of measurement have only been done for a few years in the labs, because we only know about radioactive decay for just over 100 years. Well, radioactive decay as measured now appears to be constant, but you've got to remember we think it's to do with the binding of the particles in the nucleus. And if those forces change, it's actually been demonstrated in the laboratory. It's in the literature. You can take a radioactive atom like radium, and if you are able with electromagnetic radiation to change the binding forces of the atoms, you'll change the decay rate by orders of magnitude. So it's not something that's an invariable constant. If you change the conditions under which things are existing, it's going to change the rate of decay. And that's very important because from a biblical perspective, we wouldn't necessarily expect these rates to be constant, simply because conditions changed in the past. The Bible is very clear that there's been two major events in Earth history: creation, where the laws of nature as we understand them weren't operating. We can't understand what was going on back there because it was supernatural. The only way we can understand it is by looking at Jesus' miracles and other instances in the Bible, you know, where Aaron's rod budded, where Moses' rod turned into a snake, where God supernaturally intervened and Jesus turned water into wine. Well, we know that these things can happen instant, but they don't follow natural laws that we understand. So rates can be radically different at the time of creation. And then we have the flood, where we know that from the scriptures that geological processes were catastrophic. The earth was inundated in a way that we can barely comprehend today, even from present day processes, but we try to understand that. So you would have changes there that would be catastrophic. Now, when it comes to radioactive decay, though, there's a third event that we need to take into account, because radioactive decay, and this is where there's debate amongst creationists, radioactive decay produces radiation which is harmful, gamma radiation that can damage tissues, etc. The question is, in God's good creation, very good, would there have been radioactive decay? Would there have been radioactive decay before the fall? And, or did radioactive decay only begin at the fall? That's a question that's still being debated. I happen to believe that it probably didn't start until the time of the fall, that in fact it makes sense that God at creation made all the different varieties of atoms. He made daughter lead atoms with uranium. He made uranium lead atoms side by side, which today we would interpret the lead as having derived by uranium decay. And radioactive decay only started at the time of the fall. So you have this initial endowment that God gave at creation where it had all the different types of atoms. And then at the time of the fall, instabilities occurred and changes occurred that affected some of the atoms, that they became unstable, and radioactive decay started from then on. And then it got speeded up during the flood and then slowed down to the current rates. So there's a little bit of debate there amongst creationists, but we wouldn't expect decay rates to be constant through time because we know that you can change them in the laboratory. Well, first of all, you've got to look at the fact that there is evidence, there is data, observable data, repeatable experimental data, that demonstrates the decay rates must have been radically different during the flood. And then we have to explain, well, what is the mechanism that would cause that? And if you read the reports of the research done during the Radioisotopes and Age of the Earth project, the RATE project, there were 5 lines of evidence. There was the fact that in the same crystals, zircon crystals, zirconium silicate, you would get a uranium lead age, radioactive age, of 1.5 billion years. But at the same time as you're producing lead from uranium, you're also producing helium. It's a byproduct. And you can look at the rate at which the helium leaks out of the crystal, and that gives you a helium leakage age. And the helium leakage age is only less than 6,000 years. And yet helium leakage is a well-known physical process, unlike uranium decay to lead, which is a random process. Therefore, the helium leakage age is the more reliable. So that tells us 1.5 billion years of uranium decay probably occurred in 6,000 years of real time. So that means uranium decay to lead had to have been accelerated. So that was one line of evidence. A second line of evidence was radio halos. To produce the radio halos of polonium, you needed accelerated uranium decay. Otherwise, because polonium has such a short half-life, it decays very rapidly, even today, that you needed a lot of uranium decaying to polonium very rapidly, or else the polonium radio halos wouldn't have formed. And so that was the second line of evidence. Then fission tracks, and remember, the polonium radio halos are evidence of physical decay having actually occurred, just like fission tracks. When an atom of uranium splits, it damages a crystal. And so you've got physical evidence that radioactive decay has actually occurred. And you can look at rock layers at the bottom of the Grand Canyon that are supposedly 500 million years old, and they have the equivalent at today's rate of fission, 500 million years worth, equivalent to their radioactive age. You can look at layers halfway up in the north of the Grand Canyon, the same sequence of layers, again, supposedly 165 million years old, but with fission tracks equivalent to that, and then layers at the very top of the column. And so there's a correlation, and these are layers that we know formed in 1 year during the flood, and yet they have hundreds of millions of years worth of radioactive decay in them, which means that radioactive decay had to be accelerated. And then we've got the discordant ages. We looked at layers in the Grand Canyon and dated them by all 4 different methods. And we should have got, the textbooks say we should have got the same results no matter what method we use. It's like having 4 hourglass clocks with just different size sand grains. They should have all started at time 0 with all the parent atoms in the rock and no daughter atoms, and through the same real time since their formation, they should have formed daughter atoms, and we should have been able to get the same age. And yet they got different ages, which meant that according to the sizes of the different radioactive atoms, they would have been, their decay would have been speeded up by different amounts, which you could reconcile the disparity in the clocks that way. And the last was that you get radiocarbon, which decays very rapidly in rocks that are supposed to be millions and millions of years old, fossils. And that they shouldn't be there if they truly are millions and millions of years old. So radioactive decay has speeded up during the flood. Why would that be? Well, I said before, you can show in the laboratory that the radioactive decay is controlled by the particles in the nucleus, the protons and neutrons. If you change those forces, you will change the rate at which the decay occurs. And so it seems to be that there had to be something that caused a change in the binding forces in the nuclei of those atoms. Now, here's the problem we have. You know, you can have a cause and effect argumentation. The effect is a rapid radioactive decay. The cause is the change in the binding forces in the nucleus. Well, you say, well, what caused that effect? Eventually, you're going to get back to the part where, as the scriptures say, God is ultimately in control of everything. And could it be that God allowed that to happen, sovereignly overruling the forces that were at work prior to the flood, and he started to change the binding forces? Because one of the byproducts of radioactive decay is heat. Heat drives geological processes. And so it's almost as if God turned up the dial to speed up radioactive decay, the heat generated would then burst forth with magma, burst forth with water, and you'd have the breaking up of the fountains of the great deep. So, you know, wherever you draw the line, God has always been intimately involved in controlling his creation. And at some point in the level of the chain of reasoning of cause and effect, God triggered what happened, because the flood started exactly when God wanted it to start, and an increase in the rate of radioactive decay, a catastrophic increase, was certainly a part of what happened during the flood. It is true that helium then leaks out of the crystals in the rocks, and helium is leaking out of the ground, and so helium is leaking into the atmosphere. And we can measure how much helium is in the atmosphere, and we could say, well, let's start with an atmosphere with no helium in it, and let's see how long at the present rate at which helium is leaking out, how quickly that would build up. Of course, you have to be certain that no helium is leaking out. There is some evidence that some might leak out. But even if you do the mass balance equations, you will work out that the present level of helium in the atmosphere would only get there in about 2 million years. And yet the atmosphere is supposed to have been there for over 3 billion years, according to the evolutionary scenario. And of course, that's the present rate of helium leakage. We've just talked about helium leakage was more rapid as a result of acceleration of nuclear decay. Then, of course, that brings that number down from 2 million years much less, back to the biblical timescale. And of course, we're assuming no helium in the atmosphere to begin with. Well, God may have put some helium in the atmosphere to begin with. So it really depends on your assumptions and your starting conditions, but we can easily show there's a great disparity between what we would predict as creationists, young Earth creationists, compared to the uniformitarian evolutionists that would say the atmosphere is over 3 billion years old. Helium isn't a friend to their argument at all. So for the evolutionary argument, the atmosphere is 3 billion years old or more, there's too little helium in the atmosphere for their argument. Equally, there's so much helium still in the rocks. It should have all leaked out, you know, over the millions of years.
It turns out that the evolutionary lock on dating Earth is not so secure after all. It appears to be more story than fact. Consider these 6 points Dr. Snelling made. Number 1, evolutionists extrapolate 100 years of data into billions of years, but they don't discuss that environmental changes can affect the results they tout. 2, if you don't know the starting conditions, but simply assume certain conditions favorable to a very old Earth, this can dramatically affect the results in the lab. 3, why are there discordant dates from the various radiometric dating methods? If radiometric dating is reliable, the various methods should yield consistent results, but they do not. 4, evolutionary scientists simply dismiss carbon-14 found in diamonds and fossils that are supposed to be in layers dated to millions of years old. 5, evolutionists claim Earth is 4.54 billion years old, and yet Earth has too little helium in the atmosphere to be even 2 million years old. 6, there's also too much helium in the granites for Earth to be billions of years old, as evolutionists say. From what we just learned, radiometric dating is not reliable, and it is not reliable empirical data. What do you consider to be the best empirical evidence that exclusively supports evolution? Check out my new novel, Awakening, a creation and end times thriller. In this action-filled novel, you'll learn about several empirical evidences that exclusively support creation. The novel will also give you insight into end times seen in current events. See the link on the screen and subscribe. Go the extra step and give this video a thumbs up.